Well, thank you everybody for attending this webinar today. As was mentioned, my name is Jeff Abelson. I've been with Donaldson for 13 years now, almost exclusively in our applications department, where we help our sales teams apply equipment on new applications. Hexavalent chromium has become a specialty of mine as I received many questions early on regarding applications and meeting regulations. I have done quite a bit of research and written a couple papers and presented a couple of times. It's estimated that 558,000 workers are potentially exposed to hexavalent chromium in the United States every year. Hexavalent chromium is a known carcinogen associated with lung, nasal, and sinus cancer. Today we'll talk about the new NIOSH recommendation levels, how hexavalent chromium is produced, and then finish with what next steps might be and where to get additional information. You can expect this presentation only to last about a half an hour, leaving plenty of time for question and answers. Today's permissible exposure level is set at 5 micrograms per meter cubed. May 31st, 2010 is when that new regulation came into effect. You can see that the regulation reduced from 52 micrograms down to 5, so a factor of 10. Now that exposure level is on a time-weighted average over an 8-hour period. Now the action level is the level at which OSHA regulations take effect, and that level is set at half of the permissible exposure level at 2.5 micrograms per meter cubed. What I mean by when I say when OSHA regulations take effect, there are a number of things that have to be done at that particular level. One is exposure monitoring of employees. The second is medical surveillance of employees, and the last thing is training. With training, I'll mention that your facility can either decide to do the training themselves on hexavalent chromium, or they can have an outside company, a safety style company, come in and do the training for your facility. So a couple of different options when you're thinking about that. The new NIOSH recommendation is a recommendation that came out in January of 2013 originally. The recommendation is to reduce the level from the 5 micrograms it is today down to 0.2 micrograms over an 8-hour time-weighted exposure over a 40-hour work week. That's a dramatic drop. Now in September, NIOSH came out with a revised version of that, but the recommendation did not change. The purpose of reducing it from 5 micrograms down to 0.2 micrograms is to reduce worker risk of lung cancer in a 45-year working time. I'm a pretty visual person, so I like to have some kind of an idea in front of my eyes on what all this means. And so what you're looking at on the screen right now is our 2 canisters that are 2 3/4 inch diameter by 3 5/8 inch tall. What I did is I said for a typical system where it's welding, where a majority of the weld or the hex chrome is produced, I calculated for an 8-hour day, 40-hour week, 10,000 CFM, 17,000 CMH system, how much hex chrome could be emitted or someone could be exposed to in a year. Now what I found was through those calculations at 5 micrograms per meter cubed, someone could be exposed to 172 grams per year. The canister that you see on the left is about halfway full. Then you go to the right where the new recommended exposure level of NIOSH is, and you do that same calculation, and the number turns out to be 7 grams per year. You can see that barely the bottom of that canister is being covered. So it goes without saying that that's a dramatic drop. So what processes produce hexavalent chromium? As I previously mentioned, welding is probably the single biggest producer of hexavalent chromium. And welding on stainless steel in particular is a pretty significant source. Another source is thermal spray, which is what you see on the right-hand side. And other processes include battery making, cement manufacturing, abrasive blasting, rubber manufacturing, coatings like spray paints and pigments. If somebody is chrome plating, the open baths can produce hexavalent chromium, and leather tanning. So there are a lot of places where hexavalent chromium can be produced. Now, one thing to point out is there are some good uses of hexavalent chromium. Hexavalent chromium itself can be a good anti-corrosive agent when it's added to paints, primers, and other surface coatings. And also, hexavalent chromium compound called chromium acid used to electroplate chromium onto metal parts for decorative and protective reasons is another good use. So where does it come from? Well, chromium is in the mixture of, say, for example, what you see in front of you, the welding stick or the thermal spray wire that's used in each of those processes. Or it could be in the powder for thermal spray, or it could be in the base metal that you're either welding to or you're doing some kind of process on. In the chrome bath, for example, it's in the chrome bath itself. And what you have to realize is these aren't just pure chrome. They're mixed with other materials like aluminum, antimony, arsenic, chrome, cobalt, nickel, iron, lead, moly, manganese, silver, and tin. So there are percentages of those metals mixed in with these depending on what you want for the outcome of the process. So people ask me, being in a filtration company, can I just filter or can I just see hexavalent chromium? And the simple answer is no, and it goes back to the point that I made a few minutes ago, which is that the materials used in the initial process are already mixed with metals. So when you have an overspray process of thermal spray, or you weld, or you generate some kind of fume, the fumes contain mixtures of the metals as well as the hexavalent chromium. So I like to think about the hexavalent chromium being the seeds inside the orange, where if you filter out the orange, you are going to actually filter out the hexavalent chromium. People always ask me too, well, how do I prove what level hexavalent chromium I have? And the reality is there is a specific test for hexavalent chromium. The OSHA ID is ID 2-215. It's, again, specific for hexavalent chromium. It's a test that lasts about 8 hours. And what really happens is a person properly protected for the exposure of hexavalent chromium goes into the area, spends 8 hours being exposed to the exact same things that anybody who's working in that area would. And then once the samples are taken, they get sent to the OSHA Salt Lake Technical Center in Utah, where they are analyzed. And you can see it's a time-sensitive test, so it has to be analyzed within 8 days of sampling. Essentially what they do with the sample is they precipitate out the hexavalent chromium and then report back how much hexavalent chromium was in the sample, so then you can use that to estimate how much hex chrome you are producing in your facility. If you want more information, I'd highly suggest you go to OSHA's website at osha.gov or contact them at the 800-321-OSHA. Every time that I've called them, they've been very helpful, and I have received somebody on the phone live in a relatively short amount of time. So I encourage you to do that. So I wanted to also understand, when I was doing my research, what were the hexavalent chromium inspection levels like? So there is a study out on OSHA's website. It's a 2006 to 2009 study, so it's before the regulations actually took effect. But it's called an industry sector profile. And in that profile, there were 437 records, and of those 437 records, each record being a company visited, 65% of them had hexavalent chromium in the air. Now, of that 437, 15% actually had concentrations above the current permissible exposure level. Another way to really look at that is to say that of the 65%, 23% actually had concentrations above the permissible exposure level. Now, the data, unfortunately, did not allow me to do an assessment against the action level. And it would really be nice to understand what would the levels or what would the numbers look like if we were to evaluate those same companies against the new recommended exposure level by NIOSH. Hopefully in time we'll get there. So many of you are probably wondering, what should I do now? Well, I came up with the acronym Rescue Me, so we'll go through that right now. So the first thing is every company or anybody in your facility should review your production processes. Look for those processes that could be producing hexavalent chromium. Look for materials that you're bringing in that could contain chromium itself. And then just think about how those materials and processes interact and see for yourself if you think that the process is producing hexavalent chromium. OSHA will drive everybody to eliminating the source processes wherever possible. And one example I can think of to get the juices flowing is to think about a weldment. Let's say, for example, a company makes a particular weldment and they make thousands of them in a year. Well, if you ask yourself, well, what if I took this weldment and gave it to a casting company and they made it out of a casting? Well, that would certainly eliminate the source process there, and there might even be a byproduct where your company may realize a cost reduction. So it's worth investigating your processes and the materials together and seeing where there might be opportunities to eliminate them, because you might get other benefits other than just reducing hex chrome in your facility. Lastly, if you can't eliminate them, OSHA says the next step should be substitution of alternate materials. Certainly, you have to look at your customers' requirements and make sure that whatever you're doing, you're meeting those requirements. But if you can use alternate materials and achieve the same performance as the customer expects, that's really the next step. And if you can't do either of those, or if there's just a situation where it just makes it very difficult to do those, then the next step is controlling it using local exhaust ventilation best practices. I'm going to talk a little bit more about that later on in the presentation, but just to give you a snippet right now, local exhaust ventilation means having a hood that's located close to the process, designed appropriately to pull in any fumes or any dust or mist that could be creating hexavalent chromium, and then a properly designed grouping of ductwork back to a filtration device or sending it out the building. So that's just a quick snippet of what local exhaust ventilation means. So that would be controlling it, removing it from the airspace that your employees are working in. Next is to understand the impact. Once you've done all of that work, you have to understand what you have done and whether you've made a difference. And so that may mean more testing and more evaluation. And lastly, if you've done all your work, you have to actually evaluate whether or not more actions are required, and that may force you to start over and review your processes again. So this is the first time of two that I'll remind everybody, but rotation of employees as a method of compliance to the permissible exposure level is not allowed. That's clearly noted on OSHA's website, so I just want to make sure that people keep that in mind. Involving employees and operators in the solutions that are being talked about and hoping to be implemented is certainly a good best practice for industry. You'll get adoption much quicker if you do that. So if a company finds themselves currently above the permissible exposure level of the 5 micrograms per meter cubed, there are a number of things that have to be done. One is air sampling, and I'll talk a little bit about air frequency, or the frequency of air sampling, at a later slide. But air sampling is a requirement of any company that has exposure levels above 5 micrograms per meter cubed. Next is implementation of engineering controls, which we talked a little bit about already. Respiratory protection program. This is really key, that if an area is known to produce above 5 micrograms per meter cubed today, the respiratory protection program has to be in place, and it has to be documented. Medical monitoring of employees. Remember, this level actually starts at the action level, but it's also required at the permissible exposure level of 5 micrograms per meter cubed. And demarcation of work areas. This is really important for not only employees but also visitors to your facility. You have to mark off the areas that could be producing hexavalent chromium, so people are warned of what they could be exposed to. And a part of that goes with training. Training is incredibly important. Like if somebody walks into that area, what do they need to do? Does it mean that they have to wear a respirator? Probably yes. Does it mean that they have to wear special clothes and make sure they don't wear them going out of the building? Yes. Does it mean that they also have to make sure if they worked in the area, that they have to wash their hands before they eat, smoke, or put on makeup? Yes. So those are all some things that an employee has to be trained on. There's more, but those are just some examples of things to think about when it comes to an employee training program. So air monitoring frequencies. If your facility or your particular area of your facility is above the permissible exposure level, air monitoring frequency has to be every 3 months. Now, if you're above the action level of 2.5 micrograms per meter cubed, but below the permissible exposure level, then you have to monitor every 6 months. And then if you're below the action level of 2.5 micrograms per meter cubed, then it's suggested that you do an initial baseline and then follow the facility air sampling strategy. An example that we've seen in industry is yearly. But also keep in mind that facilities change a lot. They'll change processes, they'll change materials, so it's best to really think about having a procedure that really makes you think about what could be producing hexavalent chromium in your facility, and deciding at that point when you bring it in whether you need to run another baseline. Engineering controls, as I mentioned, anything or any processes that are above 5 micrograms per meter cubed, you must, by OSHA's standards, have engineering controls. The deadline already was May 31st, 2010, so that means if you have processes producing above 5 micrograms per meter cubed, OSHA could come in and cite and penalize for that. So make sure that if you are above 5 micrograms, that you have the respiratory protection program in place. That's mandatory until engineering controls are implemented. And also be sure that when you are implementing the engineering controls, and that you also prove out how low you are actually for an exposure level. And it's up to the company to decide when it's okay to not do respiratory protection anymore. And then lastly, this is my second time noting that rotation of employees to different jobs to achieve compliance to the permissible exposure level is not permitted. So the local exhaust ventilation control guidelines. So the American Conference of Governmental Industrial Hygienists has created a book, and they're on their 27th edition, called The Industrial Ventilation, a Manual of Recommended Practice for Design. Now, this book has a lot of good information related to good ductwork design, good hooding design, gives you recommendations on fans and dust collectors and so on. So it's a good general overview of what industrial ventilation, industrial ventilation looks like in a facility. Now, the VS numbers that you see in front of you are what are called VS prints. And they are single-page documents for the most part that have illustrations and guidelines for airflow and velocities required for those particular designs. Now you can see that the ones I pulled out are more pertinent to most of our audience today, and that's for welding, robotic welding, metal spraying, torch cutting, and then laser tables. So there's a lot of good information. ACGIH does do courses throughout the year. They do them about 3 times a year at different parts of the country. So if you want to learn about good ductwork and industrial ventilation design, I'd encourage you to go out to ACGIH's website and take a look at when the next course might be available for you. Now, resources for help. So I'll start with the International Thermal Spray Association. They have some really good guidance on their website related to the processes and materials that are used in that particular industry. And they are processes that you may want to be looking for in your facility when you are evaluating where you might be producing hexavalent chromium. The California Air Resources Board has on their website, in particular for thermal spray still, some guidelines on ways to estimate by process how much hexavalent chromium you might be producing. So that's another good resource. And I do have a little bit of that information in my most recent paper, but we'll talk about that in a minute. The ACGIH website also has some good information, and that is where you can find out about the courses I just mentioned, as well as how to order those books. And then the U.S. Department of Labor, OSHA's website, NIOSH's website, the Department of Health and Human Services, and the CDC all have wonderful guidance documents out there to help you learn more about hexavalent chromium. Now, NIOSH's website in particular has the 168-page report related to the new recommended exposure level, and the basis for it, for reducing it down to that level, is also in that report. So if you want to learn more and read more on it, it's right there, so on NIOSH's website. The last thing before I mention Donaldson-Torit is OSHA does have on-site consultation services to help. So if you feel like you would rather have somebody from the outside come in and help evaluate the processes and see where improvements could be made, this consultation service is free, it's confidential, and it does not result in any penalties or citations for small to medium-sized businesses of less than 250 employees. So that's pretty decent-sized companies out there that can get this free consultation service from OSHA, and they could put you down a good path right away. So then Donaldson-Torit, as I mentioned, I've written a couple of papers. The most recent paper is out on our DonaldsonTorit.com website. If you do a search for hex chrome, you'll find the technical paper there. And so if you want to recap and learn some more information about hexavalent chromium, I'd encourage you to go out and take a look at the paper. Also on our website are a number of success stories where we have applied dust collectors to handle hexavalent chromium in many different style of applications. So I'd encourage you to go out, take a look at the products there and the success stories to help you understand how we view a good solution for filtering hexavalent chromium. So in summary, hexavalent chromium is a toxic regulated substance, and the new recommended levels may go lower in your facility. So it's best to stay on top of this and start thinking about this now. And Donaldson can help you reduce hex chrome emissions in your facility. So with that, I'll see if there are any questions.
And as a reminder to the audience, you may submit your questions by clicking on the private tab in the bottom left-hand corner of the screen. Select Leaders and Assistants and type your message into the box.
So one of the questions that I know some people have asked me in the past are, what are OSHA's next steps on this particular topic? And really the next step for OSHA is to review the recommendations given by NIOSH, decide on the validity, and then determine if they should make a new standard based on the NIOSH recommendation. If they decide to make a new standard, they call on advisory committees. And it's with these committees that new standards get developed. And once a standard is more formally developed and it's presentable, then they're made public and comments are welcome. And then revisions are made as required, but honestly I would expect it to be a few years down the road before anything may come out. So number of questions are starting to come in, and one of them is, do all welding rods produce hex chrome or only the ones used for welding on stainless? Well, it depends on the material composition of both the welding rods and on the actual material, the substrate that you're welding on. So there, on OSHA's website, there's some pretty good guidance related to welding in particular, because the fume generation rate depending on what type of gases you're using and some of the other inputs like amps and so on. So that hopefully answers your question. Another question that has come up is HEPA filtration required to properly filter out hexavalent chromium? Well, and that really depends on a number of things. Number one, it depends on the filters that you use. If you use a properly, like a surface loading filter with, say, ultraweb on it, like the nanofibers that we use in our dust collectors, odds are you may not need to use a HEPA filter. But as a protective measure, as a backup, in the event that there's an issue, it may be a good idea to put a HEPA filter on the back side just for safety's sake. Another question has come up, how close to the source are the measurements taken at the 480-minute exposure? Well, that's a good question, and I think that one is best answered by someone at OSHA who's extremely familiar with the testing. I think that you should contact OSHA at either OSHA.gov or calling the 1-800-321-OSHA. Let's see, I apologize, I'm filtering through the questions here. So another question that has come up is residue from the air filter system, any special handling? Is it hazardous waste? Well, that's a question that you have to answer with your local authorities. I would believe that hexavalent chromium is, because it is a cancer-causing agent, it should be considered hazardous waste. How to dispose of that is going to depend on local requirements. I don't believe that anybody will recycle it, as an example, so you're going to have to contact your local EPA and or waste facilities who handle this particular material or can handle this material and ask them how to dispose of it. Another question is, would grinding operations also be processes of concern for hexavalent chromium? And really the challenge with hexavalent chromium that I didn't talk a little bit about is when we have the base metals and their mixtures of the metals in particular, like on the base metal, and there's a certain percentage of it, as you're grinding it, you're heating it up. And when you heat it up, or you thermal spray it, or you weld on it, you're changing potentially the chromium state from a natural chromium of say +3 up to the 0.6. So that is where where it could be of concern. One person is saying, is it legal to exhaust outside, or does it have to be filtered? Well, that's going to depend on your local requirements, but it is, as I mentioned, a cancer-causing agent. So I would imagine many authorities would say that it's not legal to exhaust outside. Another question comes up with what type of facilities do you really see this at? And the reality is there are many facilities of ours where welding goes on, thermal spray goes on, chrome plating, even though it's being more restricted now, that continues to happen, grinding, machining possibly. There are plenty of places in our industries where hexavalent chromium can be produced. One of our attendees has asked about a particular question about our products. And the question is the TG the best filter for most of these processes, or is a DFO still the best? And really, I believe that's more on the airflow as far as which collector you pick. But the reality is both style filters have the same base type media. They have nanofiber media technology, which surface loads the material and does a wonderful job of filtration. So it comes more to, in my mind, about airflow and sizing rather than the filter itself. Another question has come up related to OSHA. People are always reluctant to bring OSHA into the mix on the front end. So is there any chance that Chilworth Technologies or anybody else like that may be able to test for hexavalent chromium? And I haven't been asked that question before, so it would be worth a call. Chilworth Technologies primarily focuses on the explosibility of the materials, but I wouldn't put it past them to be able to try to test for hexavalent chromium. Remember, too, that the consultation service is free for any employee or any company that's 250 employees or less. So, and again, it says they stress that it is a separate division within OSHA, so no citations or penalties could be inflicted on the company. How active has OSHA been in enforcing PEL recommendations is the next question, and that was kind of what I was trying to get at with that one slide. There really wasn't a whole lot of enforcement data out there that I could find, but it was mostly related to the records out there and whether or not they had hexavalent chromium in the air, and then how many were above the permissible exposure level. Another question relates to how often must you do air monitoring. So again, that depends really on the amount of hexavalent chromium in the air. If you're above 5 micrograms per meter cubed, you have to do the air monitoring every 3 months. If you're above the action level but below the permissible exposure level, you have to do it every 6 months. And then if you're below the action level of 2.5 micrograms per meter cubed today, then you should do a baseline, but then it's where I said you have to remember and think about all the processes in your plant. So if anything changes, you have to think about whether any materials or processes could be producing hexavalent chromium. Okay, it looks like that has answered most of the questions out there. If there are any other of them, please feel free to contact me in particular, and I'll be glad to answer any questions that you might have. Want to put a quick plug in for an upcoming webinar that we have coming up on April 16th for my colleague Kurt Boston. He's going to do a combustible dust strategies meeting OSHA requirements for your operation. Kurt's been with Donaldson for I think about 25 years and has extensive knowledge in this particular area. So I'd encourage you to register now at thefabricator.com/webcast so you can learn more about combustible dust strategies. Thank you everybody for attending this webinar. I appreciate everybody's time. Again, if you have any questions, please feel free to contact me.